I've always had a fascination with all things terrible. As a child, some of my earliest memories were watching B-movies with my father. Every other day we'd sit down in front of the television and watch some awfully acted, terrible costume science fiction or horror movie with the actors flailing around on stage, and I loved every single second of it. This like of terrible movies has spiraled out into a full-blown obsession with all things terrible. Now, as an adult, I enjoy all forms of terrible media, whether it's an awful film, an awful game, a truly painful book, an album that hurts the ears. Every kind of terrible media is something that I revel and enjoy. It should be noticed, though, that I want to differentiate right off the bat between mediocre and bad. Something that's mediocre won't really challenge your ideas. It'll simply bore you in its execution. But something that's bad, truly, uniquely, special bad, well, that's something different. A truly bad movie is unique in its execution. The actors and the line delivery will be bizarre, alien. Are these human beings that I'm looking at on screen? The directorial choices, camera angles, pacing, the script won't resemble that of other films. It'll leave you with a very lasting impression. A truly bad video game will make you question the very fundamentals of the medium itself. Who designed this? Was this designed for human beings to play? How am I supposed to engage with these mechanics? What are these graphics? What are these glitches? A bad book, also incredibly special. You'll read over the lines multiple times to try and parse the bizarre and strange story that the author is trying to impose upon you. No, unlike the mediocre, the truly, genuinely bad, that's something special. In examining something that is truly bad, you're forced to look at not just the object of your scrutiny itself, but the medium as a whole. What made this so bad? What makes it so unique and special? Where did everything go wrong? And in order to engage with something that's truly bad, you need to have an understanding of what makes something good. In unpacking that, something truly special and fascinating emerges. And that's the focus of our topic today. It should come as no surprise then that my obsession with all things terrible and bad would ultimately turn to my profession. Let's use an example of how we all engage with terrible code. If you've put finger to keyboard as a developer, you will have some experience with bad code. Have you ever been in this circumstance? You find yourself working on a code base, typing away, when suddenly you spot something. It's odd, it jumps out at you. I'm looking at some bad code over here. What was the author thinking? What were they doing when they wrote this? You take to the GitHub, full of righteous indignation and vigor. It's a good thing that you're there, ready to fix the mistakes of the devs that came before you. How could this get pushed through to production? I'm here to fix it. You look at the log when you see something unpleasant staring back at you. Your own name. You quietly correct the error, push it up, and then slink back into the darkness, hoping that nobody has seen this incident. This is not an uncommon experience for developers in general. We all commit bad code. And the subject of our talk today is an exploration of this bad code. What makes code bad? Well, let's start off with our first example, something I like to call jump scare code. You've all experienced this. Our previous example was about this. This is when you look at something and it immediately jumps out at you. Now, as human beings, we're conditioned to respond to various stimuli. We don't have a conscientious decision to react the way we do. And this can take on many different forms and manifestations. Sometimes we're presented with positive or uplifting images. We might see a picture of a baby, and inside we start cooing and awing. We might see a cute animal. It could be any positive response. But the inverse is also true. Reactions can be negative. We can see something which repels us, gives us fear, creates a sense of anxiety in us. We don't have a conscientious choice over this. And code is no different in that regard. Looking at our first example over here, this is not the most outrageous and egregious example of it, but anybody reading code should have a look at this and do a quick double take. What am I looking at over here? Why is this being done this way? It can and does get worse. Here we have an 11-layer deep ternary expression. Now, I've encountered these in the wild, as I'm sure many of you have, and it forces you to stop, to think, to wonder what was going on here. Why is it done like this? Our next example, I'm not proud to admit, this came from my own code over here. I'm not entirely sure what I was doing at the time, but I can say that it worked, and I'm not proud of the results. Bad code is unfortunately a necessity. We do encounter it on a daily basis. But all of these examples force us to ask the question, what makes code bad? Well, the answer, as you're going to hear many times throughout today, is that it depends. Let's start off this discussion with diving into some of the subjectivity of what makes code bad. And we're going to start off with my first entry point into good code and bad code. A controversial figure in the coding world, Robert Cecil Martin, commonly known as Uncle Bob in the community, is one of the founders of many coding philosophies. Now, I'm sure many of you who've encountered him already have your own opinions formed on him. Don't worry yet, we're going to get to Uncle Bob deeper later on this. But first, let's talk about him in the context of subjectivity and bad code. Entering into the profession, I didn't quite know what good code was and what bad code was. Being a developer, I wanted to produce good code. I wanted to produce code that could work, code that was reliable, code that was maintainable. So I turned to philosophies that I thought would help me. And Uncle Bob's clean code was my first experience with an academic principle of good code. He espouses quite a few virtues of good code, but the main points include that code should be meaningful. It should be clean and easy to read. You should separate all your functions into logical blocks. A piece of good code should read like a story. Now, I took to this philosophy with great enthusiasm, applying it wherever I could to all of my code. In my inexperience, I didn't realize that this might not necessarily be the best approach for producing good code. In fact, using this philosophy, I even produced some bad code. But this is the important part, is the subjectivity of it. As my experience with coding grew, as I became more familiar with the actual medium of coding expression, I came to understand that there really isn't a one-size-fits-all attitude towards good code and bad code. With my maturity and experience growing, too did my attitude towards Uncle Bob. And I saw that I couldn't always apply him, that there were actually times where his code made things a little bit bad, where it was a little bit unreadable. Now, we're going to dive more into this, but the point that I want to start off with is that good code and bad code is a often subjective topic. And it can be quite difficult to distinguish sometimes what makes code good bad or bad bad. Let's look at a few examples using this clean code as a philosophy. Now, here we have a piece of functioning, working code that I would personally describe as bad. Others may disagree with me, and rightfully so. But let me go into my justification for why I think this might not necessarily be good code. Does it work? Yes. Is it optimal? Possibly. Is it readable? Now, I personally do not think that this is a effectively readable piece of code. I understand it. I can look at it. But it's not apparently obvious to me what this block of code is doing. It's got strange expression, embedded ternaries. We need to hold multiple ideas simultaneously in our brain just to parse what this block of code is doing, ignoring the domain knowledge associated with it. Let's do a slight minor refactor of this, a slight push, gentle tap in the right direction of what I think might make this code better. Very minor syntactical change over here. We've mostly changed the layout of this, but notice that the effect of a slight change does on this code. Suddenly, those embedded ternary expressions are now arranged into logical blocks. It's a lot more clear now what the logical steps of this are. There's still a little bit of ambiguity in expression, and somebody not familiar with ternary expressions might balk looking at this. They might still struggle with it. But ask yourself this, is this immediately understandable by looking at it? Well, a further refactor should highlight that point a little bit more. Let's take a slightly more drastic approach to this. Let's change some of the logic. Let's arrange it into differently organized blocks and look at the effect it has. We can now clearly see each block of logic clearly defined. The return statements are explicit. We know what this code is doing. We merely need to glance at this to understand. We've transformed a densely but efficient block of code into something that reads clear and plain like a story. Is this good code? Were the previous examples bad code? Personally, I think this is good code. But does that mean that I am objectively right? Well, no. Of course not. In fact, this highlights further some of the subjectivity that surrounds this discussion. A valid critique of this might be that we shouldn't have multiple if statements next to one another. This could be argued that it's difficult to maintain. We could argue for performance. There are many, many arguments that people more experienced and knowledgeable could make about this and how it could be improved. In addition to that, all of the examples we've looked at here might even compile down into exactly the same code when we actually run the program. So what have we actually done here? We've merely transformed the code into something that I personally find more palatable as somebody who experiences and works with code. So the subjectivity of good code and bad code is at the forefront of all of these discussions and the main focus of exploration that I want to do today. So let's, for 1 second, remove a little bit of the subjectivity of it, not all of it. Let's look at the side effects of bad code, ignoring expression and syntactic choice right now. Let's talk about bugs. Now, every single person who's worked with electronics or worked with software is familiar with the concept of bugs. And these things are often a manifestation of bad code, a practical example of when code goes wrong. Here's how the end user experiences it. The origins of the word bug are numerous and hotly discussed, but it's accepted that the popularization of the phrase bug comes from Grace Hopper in 1947, who worked on Harvard University's Mark II electromechanical computer. Upon discovering computational errors when they were trying to process something, she investigated the actual components of the computer itself and found that there was a literal dead bug inside one of the relays. Removed this, stuck it on a notebook, and logged it for our enjoyment, and decades later we still refer to mistakes and computational errors as bugs. For most users, bugs have a very benign manifestation in the software that we use. It might be a small graphical glitch. It might be an exception thrown up. For software developers, bugs are an integral aspect of how we develop and modify software. In fact, there are entire philosophies designed around mitigating the effects that bugs can have on our work. We have things like exception handling. We've got memory lending. We have entire philosophies designed around mitigating our own ability to damage our own code. Despite this, we still produce bugs. Bugs are an ever-present manifestation of our coding mistakes that we cannot ignore. So let's explore a few examples of where bugs have manifested in the world and produced some positive and also some negative results. Now, as I said earlier, for most of the bugs we experience, they're benign. They don't have an effect. But this is not always the case. In fact, there are some times where real-world effects have happened as a result of software bugs. Let's explore a couple of these examples. The first we're going to be looking at is a machine called the Therac 25. If you are blessed enough to not be familiar with this, this was a piece of medical equipment designed to treat patients with radiation. It would bombard them with a small but contained dosage of X-rays, allowing medical professionals to treat very specific diseases. The Therac 25 was a modern iteration of the machine that was rolled out with brand new software and had removed some of the previous hardware safety functions that were in place. The machine was in operation without flaw for about 6 months until one of the operators accidentally, through no fault of their own, stumbled upon a software bug. This bug, unfortunately, increased the dosage of X-rays by 100-fold, bombarding patients with a fatal dosage of radiation that led to the deaths of 3 patients as well as many other complications in hundreds of others. This depressing outcome was the spark for an investigation and an international discussion of the implications of bad code. Who is responsible for this mistake? Who wrote the bad code? Should we put all of the blame on the developer who made those mistakes? Should we put the blame on the people who are managing it? Should we put the blame on the testers? Well, as it turns out, the discussion yielded that the fault took place because the machine was not thoroughly tested enough. In fact, it was discovered that different Therac 25 machines were operating on different versions of the software and that they didn't allocate sufficient time to iron out all the kinks of this new software. Instead of relying on hardware limitations previously, the new software failed. And while we don't have a definitive answer to where the responsibility lies on this, it did allow the international coding community to take these things into consideration. How does the code we produce affect real life circumstances? Another very prominent example is the Horizon IT scandal. In the 90s, the British Post Office was still operating on pen and paper principles with their accounting. Everything was done, handwritten and filed away, and they identified that this was probably not the most efficient way to handle money and transactions in their organization. So they hired Japanese firm Fujitsu to design a piece of software called Horizon. This software would be responsible for maintaining and organizing all financial transactions in smaller post offices. And when the software was rolled out, it seemed to do exactly that. What the software itself discovered was that thousands of British Post Office employees had been responsible for financial shortfalls, either through apparently negligence or theft. And this led to the legal prosecution of over 900 employees, with many convictions happening and thousands of pounds being paid out by individuals back to the post office. I'm sure you can see where this is going. Unfortunately, these shortfalls that were identified were not real. They were a glitch in the software, a bug caused by some computational error. And all of these victims, these people who were legally prosecuted and legally found guilty, found themselves in a prolonged, decade-long legal battle to try and prove their justice. While some justice has been meted out and over £58 million worth of damages have been paid back to the victim's office, it is still an ongoing struggle. So much so that it is the subject of a recent TV dramatization called Mr. Bates versus the Post Office. I highly recommend anybody interested watch the show. It's a fascinating exploration of the justice system gone wrong and software not being as reliable as possible. So these examples might seem quite dire. We set the expectation very low on the problems that bad code can have. These are real-world implications, real-world scenarios that have affected real-world people. So we might be assuming that all bugs are bad bugs. And this brings us on to the phrase, it's not a bug, it's a feature. I'm sure many of you have heard it. This is, some might argue, a coping mechanism from software developers when confronted with bad code in their code base. Not really willing to admit that the software is at fault, it's the user, or we've accidentally stumbled upon some functionality that was hidden before. It's not a bug as a feature, it has been adopted and expanded on. And this actually led me to a few investigations of where errors in software actually had some interesting or positive results. And the first example we're going to look at is a fascinating subculture, gaming. Throughout my research, gaming and software errors in games came up quite a lot. So I've tried to limit my examples here. But one of the most fascinating examples of bugs having effects is what's referred to as the corrupted blood incident, a bit of a dire name. In 2008, the company Blizzard Entertainment pushed up a new patch for their very popular multiplayer game, World of Warcraft. I'm sure many of you are familiar with it. This patch allowed intrepid players to fight against the ominously named Hakkar the Soulflare, a high-level boss who, during the fight, would inflict players with a disease called corrupted blood, designed initially to add a little bit of challenge to the fight. The original intention was that this corrupted blood disease would dissipate after the fight was finished. It did not. Instead, the disease persisted, lingering on in the players. Triumphant in their victory, they returned back to the population centers, and unwittingly, a virtual pandemic began to spread. Weaker players, upon contracting this corrupted blood disease, would succumb to it, and upon being resurrected, would once again be reinfected with it, continuously caught in a loop of death and resurrection. Stronger players, on the other hand, able to resist the health effects of this, acted as super spreaders, spreading this disease to every corner of the virtual world. The developers, upon discovering this, quickly patched it out, but the memory of this incident lingered on and had a lasting cultural impact on it. In fact, epidemiologists were attracted to this, using the data from this as a case world study, a real world model for how people spread diseases, either accidentally through ignorance or even malicious actors knowing that they're infecting, spreading it to other areas. And it was actually cited as a research example used in studying the COVID pandemic. So one might, in a stretch, argue that World of Warcraft helped in addressing the COVID pandemic. Another fascinating aspect that arose of this was the culture surrounding it. The glitch itself created a fascinating scenario which gamers had not experienced before, a virtual pandemic organically arising up through mechanics. And subsequently, many games and developers have adopted these kind of mechanics to introduce new, fun and creative ways for players to engage with their world. One could say here that the bad code that produced a bug here, served as a source of inspiration and creativity for a community. I would say that's pretty interesting and good. So this makes us ask the question, does having bad code, does having glitches or mistakes in your application make your product bad? Well, obviously not. In some cases, yes, there's real world implications, but for the most part, no, it doesn't, obviously. This begs the question, where else is bad code persisting in active products that we use? This led me down an investigation into looking at code bases that are functional, are successful, yet have bad code persisting inside of them. Now, it can be quite difficult to access code, so my options were quite limited in doing research. Furthermore, the time investment spent reading into code bases and trying to understand what makes them so uniquely bad is quite difficult. So I turned to communities for assistance on this. And once again, the gaming community proved to be a very valuable and informative resource on this. In fact, pointing me towards two very interesting sources of bad code and successful products. The first example we're going to look at is a video game called Undertale. Incredibly popular, very famous. I'm sure many people are actually familiar with this. But the circumstances surrounding the code of Undertale make it uniquely fascinating. It should be noted that Undertale is a labor of love from a single developer, one individual named Toby Fox, responsible for all of the code himself, all of the art, all of the dialogue, all of the music, everything under the banner of the single developer who worked passionately on this and released it to the world. It did incredibly well, received a lot of critical success, but the subsequent fans of this product started looking into the actual code. What made Undertale what it was? What did the source code look like? Upon getting their hands on it, some unique and interesting things were discovered about it, as you can see on the screen over here. In fact, some of the more unkind descriptions of the codebase described it as an unoptimized mess that barely functions and is riddled with all sorts of issues. Now, at face value, you might assume, oh, that's not good. That sounds bad. Why is there bad code in this? And further investigation reveals that there's some legitimacy to those claims. In fact, all of the dialogue in this dialogue-driven game is driven entirely by gargantuan, massive case statements with thousands and thousands of conditions. It's a little bit of a nightmare to work with. Similarly, another very successful indie title, a game called Balatro. The source code is very easily accessible about this, and once, as we saw before, intrepid enthusiasts opened up the source code to have a look at what made this game tick and discovered some horrifying things. The entirety of the game's logic is determined by gargantuan Lua scripts with hundreds of if-else statements. In addition, all of the card values and numerical values are coded by strings, an absolute monstrosity. Despite this, though, this raises some interesting philosophical questions about this. Is bad code acceptable? Now, gut reaction might say no, we should never produce bad code. All of our code should be good, it should be clean, it should be effective. But I would argue, and many others would, in fact, these developers serve as a testament to the fact that that answer is yes, sometimes bad code is actually acceptable. We need to keep in mind who was working on this code, why they were working on it, and how they continued to work on it. Even though this code base was an unoptimized mess, that it has bad coding practices, it was developed and maintained by single individual developers. The only people responsible for maintaining it, extending it, working on it, were people who were intimately familiar with every aspect of it. If a change needed to be made, they knew exactly where to do it. So even though these codes don't follow traditional concepts of good code, that we might objectively say, this is bad, it doesn't actually affect the product or the usage of it that much. In fact, even despite the bad code, thriving modding communities have sprung up around us with people modifying the source code to achieve certain things that they want in the games themselves. It also helps that both games were critical and financial successes, garnering the attention and adoration of millions as well as millions of dollars in actual profit. This brings up another philosophical question. Does one need to be a good programmer in order to produce good software? Complicated answer. As always, it depends. Personally, I would say the answer is no. And what we're going to look at now is a strange exploration of that. In the artistic world, there's a concept called outsider artists. I'm not sure if any of you are familiar with it, but outsider artist refers to an artist who is untraditional. Unlike many artists who have access to academic discussions of it, peers, review, outsider artists are isolated. All of the work they produce is done in complete separation from the community and popular theory. They do not have access to contemporary examples. They don't have access to peers who can review and critique their work. Instead, they go off on their own independent, unique, and often fascinating tangents when producing works of artistic expression. Outsider art can be a strange but compelling experience for somebody looking at it. I strongly encourage you to go and look at some pieces of outsider art. The emotions that they evoke are otherworldly, bizarre, alien. They don't follow traditional rules, yet there's something unique, creative, and beautiful about them. A strange manifestation of appreciation that is very atypical to what we normally experience in art. Very unique, very fascinating. This, too, applies to coding. In fact, I would say there are many examples where non-traditional code has been used to accomplish traditional effects, where coders not universally learned in common practice or who don't have access to peers will go for years producing their own work at their own pace, often creating works of beautiful, effective, but sometimes bizarre code bases. In fact, my very first exposure to code was one such example of this. When I first started working, I joined with a dev team that was contracted to an actuarial firm. Some brief context. This actuarial firm had been using a piece of in-house software for about 25 years. They'd been effectively using it, generating a lot of revenue for themselves, all done internally. It should be noted that this singular piece of software used by hundreds of employees for multiple decades was developed entirely by one single person. This developer was not formally trained. He had no formal qualifications behind him. He hadn't studied a lot of design theory, wasn't aware of common practices. Yet, he created this piece of software that was used throughout. Unfortunately, due to personal circumstances, he was no longer able to work on the project after these 25 years. And so the actuarial firm was left at a little bit of an impasse. How do they proceed forward with this? They needed the software to carry on with their operation, but they also needed people to work on it. They needed to decide, do we continue maintaining this piece of 25-year-old legacy software, or do we rewrite it using our own team with our own modern methodologies? Well, they decided on the latter, and the team that I joined for my first occupation, for my first job with coding, was the team working on this. Now, by the time I joined, they had already been working on this project for a couple of years and had made some headway into bringing this program into modern design patterns and paradigms. It was my responsibility to do a lot of the grunt work, the simple things that didn't need a lot of attention. So my job mostly focused around rewriting SQL queries, designing some very basic UI functions, taking obscure bits of code in the codebase and translating them into the language that we use and bringing that functionality across. It was a harrowing experience. In fact, the code I saw in those earlier years shaped and altered my perception of good code and bad code. Now, initially when I first started, I had a very limited focus on it. I didn't understand the scope of the application. All I saw were like those examples we explored earlier. Bad code staring at me. Code written with no obvious intention, no theory behind it, no thought or consideration as to how other people would be interacting. It was a truly difficult experience, and I struggled immensely trying to translate mistakes that another developer had into modern design practices. But the more I experienced this, a strange thing started happening. I started appreciating and actually enjoying some of the code that this individual had designed. Not to say that the code was good, but as my focus began to expand, as I was able to see the picture of the software that this man had created, I began to appreciate the sheer scale of what he had accomplished. With no formal training, with no knowledge of theory, this man had created something truly remarkable. Functionality we often take for granted now, he had written by hand. Sorting algorithms that defied logic. His own implementation of link query truly inspirational functionality, albeit written in the worst possible way imaginable. As my experience continued to grow, I started to see the whole picture, and I formed an attitude towards this that was actually shared by many in the team. This man had created a cathedral, a testament to hard work and enthusiasm and passion for a project. In fact, we in the team affectionately started referring to this original source code as the Sistine Chapel, a true monument, an accomplishment of human endeavor, albeit one made of poo. This served as the main impetus for me for exploring bad code. How was it possible that somebody so simultaneously awful at code was able to create something that was genuinely complex, truly incredible in its execution? That contrast in it really evoked a sense of wonder in me and sent me off down the tangent of trying to find what makes code good or what makes code bad. Which brings us on to the most fascinating aspect of good code or bad code, and that is the culture that has sprung up around it. There's different aspects of the culture that I'd like to explore with you today, and it really brings out the subjectivity of it and how different attitude towards bad code can create different interpretations and different cultures. Let's explore some of the cultural aspects around good code and bad code. Now, as we've discovered here, bad code is an incredibly subjective experience. It makes sense then that communities have sprung up around the subjectivity. Groups of enthusiastic individuals who revel in bad code, who like to discuss how they can make it better, how they can make it worse, and how to involve themselves and explore the various different things that bad code has to offer. We're going to start off with one of the most common manifestations of bad code, and that is the average developer's relationship towards bad code. As the story in the beginning highlighted, to be a software developer, you will be working with bad code, either through your own code that you yourself have produced or through reading other people's bad code. And we've developed a somewhat bizarre relationship with bad code. The general attitude I've experienced with most incredibly senior developers is that if it works, don't touch it. Just pretend that the bad code isn't there. And there seems to be an almost Stockholm syndrome developing around bad code, a strange abusive relationship where we accept the problems in bad code. But why? Why do we accept that? Well, there's good reason for that. I'm sure many of you have had this experience of first joining a team or first working on a piece of code and enthusiastically diving headfirst into it, seeing an obvious problem and doing your absolute best to refactor it, to make the project better. Junior developers and myself at times have enthusiastically done this, only to see their efforts spiral out of control in front of them. What seemed initially like a small, minor change to a single class ultimately expands and blows up into a system-wide refactor, while the experienced developers nod on, simultaneously feeling nostalgia for the enthusiasm and dread for what the developer is about to experience. Senior developers or more experienced developers have this strange relationship towards bad code, and I'd like to explore a few manifestations of this, some of the ways in which we try and cope with bad code. I took it upon myself to pour through some repositories as well as some Stack Overflow comments to find some nuggets of some nuggets of gold in the community on how we approach bad code. And I'd like to explore a few comments that I read in Codebases. Dear maintainer, once you are done trying to optimize this routine and you've realized what a terrible mistake that was, please increment the following counter as a warning to others. Total hours wasted here, 42. Experience with bad code can sometimes lead you to believe that sometimes the effort it takes making that bad code good is not worth it. In fact, we've all spent time refactoring bad code only to have it blow up in our face or to waste countless hours. Sometimes it is better to just leave things as they are. There are also cases where you can know that you're writing something bad. You can know that the code you're about to commit is bad, but you're inescapable to do anything about it. I dedicate all this code, all my work, to my wife, Darlene, who will have to support me, our 3 children, and the dog once it gets released into the public. The constraints of deadlines, of pressure, of simply getting working code out the door can sometimes lead us to do terrible and uncomfortable things to our code. We can sometimes know the atrocity that we're writing, but be powerless to do anything in front of it. A train hurtling towards us that we are unable to move out of the way of. An unfortunate reality of the job. When I wrote this, only God and I understood what I was doing. Now only God knows. We've all had the experience of looking back on our code and wondering what the heck we were doing, trying to divine meaning out of the headspace we were in, be it years, months, or even in some cases, in my case, weeks ago. Sometimes bad code is inescapable from the experience of being a developer. We need to learn how to appreciate and understand and work with it in our day job, because if we have a complete intolerance to bad code, it's going to make for a very difficult work environment for us. The other cultural aspect I'd like to dive into is academia and the academic attitude surrounding bad code, as there's some very fascinating truths to be discovered in this. I'm sure many of you have discovered taking to the internet, enthusiastically Googling a problem you're having and praying to goodness that the first answer that comes up in Google is a Stack Overflow answer to exactly your problem. Upon diving into that, you'll see that there are many different answers. Sometimes discussions can get a little bit heated and angry, but there's very rarely one single answer to the problem that you're having, if in fact there is an answer at all. My own exploration to academic circles and academic discussions of bad code online have really emphasized the subjectivity of it all, showing me that there are an infinite amount of approaches, and that often transforming bad code into good code comes down to a matter of subjectivity and experience in the code base you're working on. In addition to that, there's many other academic spheres we can study. Lots and lots of textbooks and fantastically written academic texts exist which will attempt to inform us on what approaches we can take to produce good code, how we can avoid bad code. Which brings us back to one of the most controversial figures in the coding world, Uncle Bob. Now, earlier on, I did promise we'd come back to him, and something I've tried to emphasize throughout this is the subjectivity and ever-changing nature of bad code. What's considered good or bad can literally shift depending on the person you're asking, or even the time of day you speak to them. And Uncle Bob is a wonderful personification of this very thing, how attitude towards good code and bad code will differ drastically. Now, upon researching this topic, I decided to investigate my own biases, to look back at where I began my journey into studying what made code good and what made code bad. And I reread a lot of his works and endured a lot of Uncle Bob's YouTube videos. He is a fascinating individual, but I studied him in isolation from the community as a whole, not able to appreciate where he stood in the greater context. And upon looking at the community's approach to Uncle Bob, I was not ready for the vitriol that I experienced. He is one of the most controversial figures, ignoring completely his personal attitude towards things. Just his coding approach often brings out some very interesting and often quite fiery discussions. He is often criticized, especially clean code. It's criticized as actually being bad, despite me assuming it was good. There's a lot of subjectivity. In fact, people can make a very articulate argument as to why following his philosophy and cleaning up your code can actually make a code base less readable. In addition, there's some very good examples where people have taken the code examples in his book themselves and shown how he isn't following his own philosophy and how that code itself is actually harmful to the health of a code base. The inverse is also true. There are many examples of people who have, in fact, adopted his philosophy, have refactored their own code to follow the clean code principles, and it has been a boon to their productivity and the overall health of their code base. So, what can we actually say about his attitude? Clearly, he's experienced. He knows what he's talking about in some regard. Clearly, his work is valuable to some, but harmful to others. He himself really serves to highlight the subjectivity of what makes code bad. In fact, he himself, I think, is aware of this and the ever-changing nature of what is good or bad, because recently he announced a total from-the-ground-up rewrite of his book, Clean Code. I myself will be looking into that and seeing if he's adopted some of his principles and addressed some of the concerns I personally have with him. But I think it's important here to distinguish that the academic culture surrounding bad code is ever shifting, ever evolving, and ever subject to the whims of subjectivity. Another fascinating cultural aspect to examine with bad code is the influence it's had on gaming. Entire gaming communities exist where they explore bad code. I'm sure you've seen speedrunning or you're aware of it. These communities exist to try and break games in creative ways, to try and accomplish feats not originally intended by the developers. In fact, a lot of people have gone out of their way to unpack the source code of games and try and find new and creative ways of exploiting oversights by the code, exploiting those snippets of bad or irresponsible code to create new and exciting environments. As we saw earlier with the Corrupted Blood incident, sometimes bad code can lead to truly creative results in the gaming circles. One of my favorite aspects of the subculture is akin to my enjoyment of bad films and bad games, and that is a fascination with the culture of what makes something bad. And this is best exemplified by what I like to refer to as enterprise applications. Now, I'm sure many of you have heard of Hello World or FizzBuzz, simple examples of code which are designed to express simple coding concepts expressed simply and elegantly. These enterprise applications are the opposite of that. They take these very simple concepts such as Hello World and add good design practice onto them, abstracting and complicating things which we would expect to see in a production environment. Gone are simple string interpolations. Now you are obliged to add layers upon layers of abstraction on to accomplish simple things. In particular, these have very active communities with active GitHub repositories, people often contributing, discussing what features and abstractions can be added to this. And in many ways, they serve as kind of the inverse to bad code. They show us, they almost satirize the practices of good code, showing us how adding on layers of abstraction onto an application for the sake of achieving something that is good can often be arbitrary or at some points even harmful to the application itself. A fascinating community to delve into. The final community I'd look into doesn't have a codified name, but is a kind of parody of the concept of coding golf. Coding golf as a topic requires people to take existing pieces of code and then slowly but surely iterate on it, pass the code from one developer to another, with each pass making minor changes to it, minor optimizations. After 5 or 6 passes, an initially densely, somewhat clumsily expressed piece of code can be reduced down to beautiful, simple, elegant coding expression. This community I found is the opposite of that. Reverse coding dumpster diving, if you will. It takes the practice of taking an existing piece of code and slowly making it worse and worse and worse while maintaining that functionality. Let's have a look at a simple example over here which illustrates the concept. Initial expression, clean, straightforward, and as each stroke of reverse coding happens, we add on additional layers of trash onto this code, where eventually we're left with something that is barely decipherable, barely readable. Now, this is a simple example, but this can be extended into some truly hilarious and amusing examples. So, at the end of all of this, what do we actually have in terms of discussion of what makes code good or bad? Well, as we established earlier, it depends. Bad code is an entirely subjective topic, one that has birthed communities and is fascinating to examine. But what can we actually say about bad code? What truths can we actually take away? There's only really 2. Firstly is that bad code is unmaintainable and that bad code produces unexpected results. But is that enough to truly encompass the idea of what makes code bad? I'm hoping that by the end of this presentation, I've shown to you some of the cultural and interesting aspects of bad code and encourage you to take this as a first step in joining me in this community of fellow trash enjoyers and explore what makes code good bad or bad bad. Thank you.